The other approach we can take, the preferred approach, is rather than to write our code directly in the user interface classes, that we create our own class and have that class interact with the user interface in a more hands-off way. And so what I've got here on the screen is the three components that are required in order to make that happen. So let's start with the XAML. So here in the corner, you can see that I've added several things. So the text box now has a binding operator. So the text is now bound to something called operand 1, and I've set the mode to two-way, and the mode meaning two-way means that it's going to allow the user to set the value, and it's also going to allow the value to be displayed in the view. And I've done the same thing for the text box, the other text box, and I've done a similar but not quite the same thing for the text block that was the result. And the reason I haven't done two-way for the result is because we're only going to display changes. We're never going to, because a text block doesn't allow the user to type anything in. We don't need to know what the user typed in to send it back to us. All we care about is, hey, we're going to display it out. So that's the one default, is the one way going outwards from our new object, which we'll talk about in a second, out to the display. So that's what we need to do in the XAML. We need to specify a binding between this object that we're about to create and the XAML. Okay. Second step is we actually need to create this object. So here I've created a class that I've called calc, and just like our main window inherited from window, our calc class is going to inherit from something else, and it's going to inherit from this iNotify property changed thing. And iNotify property changed is a way of allowing us to communicate between this object and the view. And specifically what it's going to do is it's going to use this code down here. And this code down here is something that we can just copy and paste into every one of our projects. We don't really need to worry about the actual values. I will explain a little bit though. What's going on is that we are checking to see whether anybody has populated this value, and it's an event handler, just like our button click was an event handler. We're creating our own event handler here. And if somebody is there, in other words, if this object is not null, null being the meaning of it's empty, there's nobody there. If it's not null, then we're going to invoke the listener and say, hey, this property has changed. And by default, the way this parameter works with this caller member name thing here is that it by default will be the property name of the property that we're in. We can also specify another property if we want, but we're not going to in this particular case. Okay, so basically this code down here, copy it, use it, don't change it. Now, things that are specific to our particular application. So we refer to something over here in the XAML as operand 1. Well, over in our object, we have this thing called operand 1. And we had operand 2 over here, and we've got operand 2 over here. We've got result, and we've got result. So the names that are found in the XAML match the names that are found in our calc class, calc object. So what we're going to do here is we're going to, and so this is the internal form of a property. So, you know, we've referred to other things having properties. The .text is a property. The text is a property of that Windows object. So we're just using that capability, but we are creating our own. And properties have a get and a set method. So they're a combination, a hybrid, if you will, between methods, because you can call things, you can execute code, and variables. And because they're this hybrid, we call them the special name, we call them properties. So these properties that we created for operand 1, operand 2, and result, we're saying over here that we want to work with them in our XAML. So, and because we made mode equals two-way for operand 1, for example, it means that whenever the user types something into the text box and then moves the focus away, the view will know to execute that code, and our copy of operand 1 in here will change to the value that the user typed in. Same for operand 2. Because result is not two-way, then whenever we modify result internally inside our object, the view is listening for that. When it gets notified of that, it will update the user interface. And how does it get notified? Well, it's our call to notify property changed. So this thing that I said we don't have to worry about, we're actually going to invoke it every time we do a set, because when we do a set, that's when we notify and say, hey, I have somehow changed. So we've got our notify, which alerts the view and says, hey, view, something has changed, go and update it. And we've got our internal values, which are reflected in our getters and setters that are replying back to whoever is asking for our external representations. And finally, we have this add method, which will take operand 1, add it to operand 2, place it into result. Now, we have one more piece to go. In our main window, we need to do two things. First, we need to make an association between this particular object and this view. And how we're going to do that is this line right here. The data context equals calc. So we've created a new calc object, and then we assign the data context to be that object. So now what we're saying is, hey view, here's the object that has something called operand 1, something called operand 2, something called result in it, and you should be using that object when you're trying to update your interface. And also, view, please listen for changes so that you can update yourself whenever necessary. So that's the first step, is we need to make a link, and that's how we're going to make that link, is by creating this new calc object and then setting it, the data context, to it. Then finally, we still need to do something on the button click, but this time, instead of all that other code, what we need to do is we need to call our add method, and that's all. So once this add method gets called, which is this thing here, it's going to do the calculation, set the result. The result will call notify property changed. Notify property changed will let the view know that that happened. Because there is a binding, the view will say, oh, I need to update this value and display the correct value. So now if you implement this code exactly as is, then you'll see that that in fact happens. So there's a couple of advantages to this, obviously. One is that if we decide to change our view, we don't need to change our calc sum or calc object. But also, if you've noticed, all that stuff about try parse and catching exceptions, we don't have to worry about any of that because this is all going to be taken care of for us by the view, by the interaction with the interaction with our object, because it's not going to place a non-integer into operand 2 or operand 1. It's only going to place integers. If you type in a non-integer, it's not going to let you do that, or it's at least not going to try to provide it. So all that handling that we had to deal with, gone away. So that's the big advantage of this MVVM framework.